In our previous classes with regards to digital control systems, we have discussed the motivation for digital control systems, and we have discussed various types of signals that are incorporated in the digital control systems, and eventually we have discussed what are the various continuous time analog signals, continuous time quantized signals, the sample data signal and digital signal. Now we are going to discuss today what are the various components of digital control systems, which we have already discussed in the block diagram of digital control systems in our previous class, where we have the analog to digital converter, we have digital to analog converter, we have the sample and hold circuits, the plant and the transducer. Out of which we know what is a transducer. It is a device which converts any non-electrical quantity to an electrical quantity, and the plant is the system or process upon which we are working on. And analog to digital converter and digital to analog converter are a part of the digital control systems, where you will have the data conversion from digital to analog and analog to digital conversion techniques, which we will be discussing in length in the later stages of our lecture series, and the sample and hold circuit. Now we will see what is a sample and hold circuit. Before going into that, what are the types of samplings that we are going to encounter while discussing digital control systems? Types of sampling. Types of sampling processes. One, the most important and the most easily used, famously used sampling is the periodic sampling. The periodic sampling, where the sampling occurs at various discrete instants of time with equal time variations, or you can say Tk plus Tk or Tks, where K is from 0, 1 to so on. Now at various times, so that is, we have values at T0, T1, T2 and so on. You have instants only at various instance of time. You have values, magnitudes of the signal at various instances of time, and in between T0 and T1, that is between Tk plus 1 and Tk, you doesn't have any value. We are going to lose certain information between Tk plus 1 and Tk. That is why the sampling duration, sampling period T must be reduced as much as possible. For example, if I wanted to, if this is the T and x of Kt, I have here T, 2T, 3T, 4T. For example, I have the signal like this at various instances of time. Now if the time period T is a bigger value, then you are going to lose certain information between 0 to T and between T to 2T and 2 to 3T, etc. So this is a periodic sampling, that is a sample which exists for various instances of time. You are getting values of the discrete sample data signal at various instances of time only. In between you will not be having any type of value that is existing. Now the second thing is the multiple order sampling. Multiple order sampling. That is Tk plus R minus Tk. This instance repeats after every Tk plus R minus Tk. So this is multiple order sampling. And the third one, you have multiple rate sampling. Multiple rate sampling, where in this multiple rate sampling you will have a big system. In a big system you will have multiple loops. When you are having multiple loops, you will have varied time constants. So the smaller time constants, the loops having small time constants, and the loops having large time constants. Loops having large time constants. In order to synchronize all these, what we need to do is, because these are all existing in the same system, multiple loops in the same system, therefore you will have to, for smaller time constants, the loops having smaller time constants, you will have to use a faster sampling, faster sample rate. You have to sample the signal at a faster rate, and here you will have to slower sample rate. sampling rate. For the larger time constants, you will have to go with slower sampling rate. That is the multiple rate sampling. And the fourth sampling and the last one, you have random sampling. The sampling is done, the sampling instants are considered at various random instants of time. So these are the types of samplings that are used in this digital control systems, where periodic sampling is most famously used. Therefore, periodic sampling can be used easily without any haphazards in the system. Now we will see, once we have understood what are the various types of samplings we have, and we are going to use in most of the cases in the lecture series we will discuss about periodic sampling. Now we will try to understand what is a sample and hold circuit. Sample and hold circuit. Both are different processes. Sample is using some periodic sampling or any of the samplings. You will try to sample a given continuous time signal and you will get, for example, let me say we are having a continuous time signal x of t which is sent here. For example, let us say I am having continuous time signal x of t here. Then let me say it is a switch. Already we have discussed that sampler is a rotating switch which is connected, which comes in contact with the other part of the circuit, or I can call it as x star of t, the output of the sampler. Let me call this as a sampler or a rotating switch. A sampler or a rotating switch, you can say, with time period t, if it is coming in contact with that is the rotating switch indicates this switch comes in contact with that, opens and again comes in contact with that. For that time period it is taking time t. That is called the sampling period. Now this rotating switch once it comes in contact with this, you are going to get a signal which is a sample data signal which can be called as x of kt. Right. So for every instant of time at 0, for example, if the switch is in contact with this, at time t is equal to 0, I have this value. This value will be represented here, and after time period t, the signal is here, and after certain time period again the signal is here, 2t and 3t and 4t. So this is our sample data signal. This is a sample. The output of the sampler is this one. Now for this, a hold signal is a hold device is this sample data signal is given as input to the hold signal. That is a signal which is sampled, which has got only values at discrete instance of time. If it is given as input to the hold, what this hold circuit will do, you will get a continuous time signal again. You will get a continuous time signal, but you will get a staircase signal, which indicates, let me represent this output as h of t, which is a continuous time signal. For this, what we try to do is, what will happen with the whole circuit is, at time t is equal to 0, what is the value at this sample data signal? It is some value here, and that will be represented here, and until the next instant where you are getting some other value with a different magnitude at time t, at time capital T. So this signal will be held until the next instant. This signal will be held until the next instant. That is the meaning of hold. The hold indicates it is holding the value of the signal, from 0th instant to the next instant. And at time t is equal to capital T, the value of the instant or the value of the magnitude has changed. It is from here. So you are getting, then that value will be held until the next instant, 2t. Again it will be increased, and okay. So 3t, 4t and 5t. So that is how you are getting a continuous time signal again here with the after the whole circuit. So this is a sample and a whole circuit. The process, what are the various processes that are happening in a sample and whole circuit. Once you give a continuous time signal to a sampler, which is a rotating switch rotating at a time period of t, capital T seconds, then you are getting a sample data signal which is x star of t or x of kt. This x of kt will have values only at discrete instance of time, and if this signal is given as input to the whole circuit will try to convert this sample data signal which has got values only at discrete instance of time into a continuous time signal, but it is a staircase signal. It is something related to a staircase signal. So after this, now how is this happening? What is the circuit behind this operation? Is, for example, the sample and whole circuit, I can use two amplifiers, op amps, a sampler here, and here I will place a very high quality capacitor, C, which has got very low dielectric constant and very low absorption characteristics, and you are giving the continuous time signal here Vi, for example, an input signal, voltage signal Vi, and this is our op amp which is given here, and the sampler is here. That is, with the help of sampler we are trying to give the sample and hold command. Sample and hold command is given here to this sampler, which is a rotating switch. It comes in contact with this, and this high quality capacitor will try to track the value of the input signal, and holds it. Once this gets disconnected, the capacitor will hold that value whichever is tracked. This value is charged, the capacitor is charged with this value at 0th instant, and until the next instant the capacitor will hold that value and keep it at this value until the next instant it reached, and from that value again once this comes in contact with this, then again the next instant will be immediately the capacitor will be charged. So here for this purpose we require a high input impedance, this buffer amplifier, high input impedance buffer amplifier, and also high output impedance buffer amplifier is required here, and this is a very high quality capacitor, so that this capacitor has to instantly charge and discharge as and when required. That is the reason why you are going for a high quality capacitor, and which is having low dielectric constant and which is having low absorption characteristics. So this is a sample and hold circuit, and with this device you are going to acquire this output. From a continuous time input you are getting a sample data signal, and then you are going to get a continuous time 0 hold output in this.